Here are some examples of using the area formulas that were discussed in the previous video. I'm on page 25 in your workbook going through these examples. Usually what I like to do when I'm doing any area problem is I like to start with the formula and then simply fill in the pieces based on the variables that I need. So for example, the first one's a rectangle, and I know the area formula for a rectangle is length times width. So I can see that the length here is 5 and the width is 3. So again, many of you can probably do this in your head, but I'm showing you the process. Start with the formula, fill in the pieces that you have, and then it's a matter of just following that formula. So in this case, the area is going to be 15 centimeters squared. On the second one, it's a parallelogram. Start with the formula. The area is the base times the height. The base would be 12. The height is the segment that's drawn perpendicular. I see the 90 degrees, so my height is 9. So I have to take 12 times 9, which would be 108 feet squared. And then I get another rectangle, so my area is equal to the length times the width. So the length I can clearly see is 8 times the width, which is, I don't know. So here's where you might have to start doing something else in the problem, which is why I write the area formula first. That's what I want to do, but now I have some side work to figure out what that width is. So in a rectangle, I know that all the angles are 90 degrees, so I'm going to focus on that right triangle that was created by the diagonal. So I had 8 and a diagonal of 10, and I'm interested in the width. Well, I'm going to do a Pythagorean theorem here. I know that the width squared plus the 8 squared equals 10 squared, so the width squared plus 64 equals 100, which means the width squared equals 100 minus 64, which is 36. And then if I square root both sides, I'm going to get that the width is equal to 6. So that's just what the width is. My goal is to find the area, so it's going to be the length of 8 times the width of 6 that I just found, which is a total of 48 centimeters squared. And that's why we start with the formula. That's what I want to do, but then I had to do some side work to find one of those missing variables. So we turn the page and we see something like this. Now this is not a parallelogram, a rectangle, a trapezoid, anything. So what we need to do is cut it into pieces. So by drawing a line right here, what I've done is I've created a rectangle on the bottom and a triangle that I can find up here, and then I'll add them together. So my plan is to take the rectangle plus the triangle. So the area of a rectangle is the length times the width. The length of that rectangle is 16 times the width of 5, which has a total area of 80. Now the area of the triangle is going to equal the base times the height divided by 2, or 1/2 base times height. Now I got to do a little figuring here. The line I drew is perpendicular, and 5 was the width of the rectangle, leaving me 5 left over for this segment of the triangle. And then if this part of the rectangle is 8 up to this point right here, then the rest left over from 16 would also be 8. So I'm just going to make a rough sketch of that triangle over here now with the new numbers that I've put on it. There was 5 and there was 8. Now I can clearly see that the 5 is being drawn perpendicular to that side of 8, which makes it the height. So my height is 5 and my base is 8, so my formula is going to be 1/2 the 8 times the 5, which is going to be 20. So I have to add those two pieces together, the rectangle plus the triangle, which would be a total area of 100 inches squared. On the trapezoid problem, this one's pretty straightforward. I've got the perpendicular here. Doesn't appear to be marked, but that is perpendicular. So I'm going to say my area formula is 1/2 the first base plus the second base multiplied by the height. So I have 1/2, base 1 is 6, the second base is 14, and then the height is 7. So that means I have 1/2 20 times 7. Now 20 times 7 is going to be big, so what I like to do is take the half times the even number. So half of 20 is 10, multiplied by 7 is going to be 70 centimeters squared. On the rhombus down here, I have to look at what I have. It says UV, so from U to V is 10, and from U to, oh, I got that backwards. Let me start over. From U to V is 10, and from U to W is 12. Now remember, the area formula for a rhombus is 1/2 diagonal 1 times diagonal 2. Well, I don't have both diagonals. I have one diagonal there in pink, which is 12. So I'll start with that, 1/2 the diagonal of 12 times the second diagonal. Now the second diagonal is going to be this length of Vx is what I need. So I'm going to have to use some properties of rhombus to figure this out. If UV is 10, that means all the sides are 10 because in a rhombus they're all the same. And if UW is 12, that diagonal gets bisected into a piece of 6 and 6. And one of the properties of rhombus is that the diagonals are perpendicular. So what I'm going to focus on is this triangle right here. Because that triangle, let me sketch it over here, that triangle is a right triangle with a hypotenuse of 10 and a base of 6. And we actually just did this Pythagorean theorem on another problem. This is a 6, 8, 10 Pythagorean triple. So that means that the length of that midpoint to V is going to be a total length of 8. And if that length is 8, the other side of that diagonal is 8. So the total length of diagonal 2 is going to be 16. So that means I'm going to take 1/2 of 12 times 16. Half of 16 is 8. So I'm choosing to do the bigger number first to make this smaller. And then I do know that 8 times 12 is 96. I'm going to have a total area of 96. And since the units weren't specified, I don't need to specify units, but I could say if I wanted to, units squared. So that one is a little bit more involved to find that problem. On the kite question, this one not nearly as bad. The area formula is still 1/2 diagonal 1 times diagonal 2. I can see that the first diagonal full length is 8, and the second diagonal would be the two pieces of 2, which is 4. So I have 1/2 of 8 times 4, which would be 16 inches squared. A lot of times when we do area problems, I'll just write you a question without drawing you a picture. So you need to practice drawing the picture for yourself as well. For example, it says the area of a triangle is 48 square inches. If the base is 12 inches, what is the height? Like all the problems, I start with the formula. The area of a triangle is 1/2 the base times the height. Well, they're giving me some of those numbers. It says the area is 48, and it says the base is 12. So I'm going to plug those into my formula. This means 48 equals 1/2 times the base of 12 times the height. This is just an algebra equation that I need to solve now. This means that 48 equals 6 times the height, and then I can divide both sides by 6. This has to be a height of 8 for this to hold true. And the next example says if the area of a square is 64 centimeters squared, what is the perimeter? Well, let's just sketch that out for a second. The area of a square is always equal to side squared. So if the area is 64, that means 64 equals the side squared. If I square root both of those, 8 must be the length of the side of that square. And since I know all four sides of a square are the same, it's 8, 8, and 8, the perimeter is going to be 4 of those sides of 8 for a total perimeter of 32 centimeters. So again, combining the properties and the area formulas to answer this question. The next question, the length of a rectangle is 2 less than twice its width. This is going to be a little bit more involved because now I have to use an expression to represent the rectangle. So first I'm going to sketch a rectangle. So here's my rectangle. And it says the length is 2 less than twice the width. So that means that the length equals 2 less than twice the width. And the width is just that, it's the width. I don't know what that is either. So when I do my area formula is going to be the length times the width. But since the length is equal to an expression 2w minus 2, I'm going to say that the area is equal to 2w minus 2 times the width of w. Which when I distribute that w into that equation, I get 2w squared minus 2w. But it does tell me that the area of the rectangle is 40, so I could have plugged that in for area. And when I do that, I get this equation, 40 equals 2w squared minus 2w. So what I know is I can solve this quadratic equation using factoring or completing the square or quadratic formula. So I'm going to subtract that 40 to the other side to create an equation that says 2w squared minus 2w minus 40. So now I notice that there's a common factor of 2, so I'm going to divide everything by 2. So I get 0 is equal to w squared minus w minus 20. And if my factoring skills are up to par, I can see that that would factor to w minus 5 times w plus 4, which means my answers to w would be 5 and negative 4. Now, negative 4 doesn't make any sense for a width because I can't have the length of a triangle be a negative number, so I'm going to toss that one out, which means my width has to be 5. Now, it did say find the perimeter, so 5 isn't my final answer, so I probably shouldn't circle that. That's just part of the answer I know. If the width is 5, that means my length is going to equal 2 times that 5 minus 2, which would be 10 minus 2, or 8. So my length is going to be 8, and my width is 5, and I know that the opposite sides are congruent. So when I find this perimeter, the perimeter is going to equal 5 plus 8 plus 5 plus 8, which is going to be 26. So make sure you answer the correct question as well, because looking for the perimeter of that, but to do that I had to use the area formula to find the width and the length to find that perimeter. That's a very good test question you might want to be aware of. The next one says the perimeter of a rhombus is 68 feet and the length of one of the diagonals is 30 feet. Find the length of the other diagonal and find the area of the rhombus. Again, let's sketch this out so we can see it. I know that in a rhombus, all 4 sides have to be the same. So I'm going to do my best to keep them the same. And it says the perimeter is equal to 68. Well, there are 4 of those sides, so 68 divided by 4 is going to give me a total side length of 17. So I know that each of these sides on this rhombus are going to be 17. And it says one of the diagonals is 30. Since I don't know which one, it doesn't matter which one I draw, so I'm going to draw this one is 30. It says find the length of the other diagonal. So I'm going to draw that other diagonal in there. And that diagonal is going to cut this in half to 15 and 15, and at the same time be 90-degree angle with the first diagonal. Well, this is much like a problem I did up above. I have a triangle now with a hypotenuse of 17, an unknown length that I would like to know, and a 15 that I do know. So I'm going to do a Pythagorean theorem here that says x squared plus 15 squared equals 17 squared. And you can figure that out, and you should get that x is equal to 8. So if this length is 8, the other part of that diagonal is 8, so that means the second diagonal is equal to 8. I'm sorry, 8 times 2, because there are 2 parts of that 8. The second diagonal would be 16. Since it then asks me to find the area, I know that the area of a rhombus is 1/2 the diagonal 1 times the diagonal 2, which would be 1/2 of that 30 times 16, which is equal to 240 feet squared. And that would be the area of my rhombus. On the last question, it says find the area of the parallelogram that's given by the coordinates A, B, C, and D. So let's start a new page, jot down our points, and actually plot this parallelogram out. So it says A is 2, 1, so 2, 1. B is 10, 1, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. There's B. It says C is 13, 5, so if this was 10, 11, 12, 13, 1, 2, 3, 4, 5. And then D was 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it says it's a parallelogram, so we don't have to guess that it is, or in fact prove that it is, which we could if we wanted to. So it says find the area of this parallelogram. I know the area of the parallelogram is always the base times the height. Well, they've been very nice to me on this question because I can just count the base. 1, 2, 3, 4, 5, 6, 7, 8 units, so the base is 8. And remember, the height is always drawn perpendicular. So I could start at this vertex D and draw straight down, and that's going to represent my height. And I can count that too. That's a 1, 2, 3, 4 units in length. So the area of this parallelogram is simply 8 times 4, or 32 units squared. So even though it started as a coordinate problem, don't let that freak you out and think you can't do that. Once we plotted it, this became a very simple base times height, and we could count both of those numbers. All right? Try the rest of the problems in your workbook and see me if you have any questions. Good luck.